Hello guys, I will be explaining LeetCode question number 1637, wildest vertical area between 2 points containing no points. Okay, so in this question we have to find the maximum width of any 2 points where there are no points in between. So what do I mean with the width? Which is the horizontal distance between any 2 points, right? That will be considered as a width. So in this question we have to find the maximum width between any 2 points. Okay, so here as you can see the maximum width this one, right, which is this, right, and this, and there are no points between these 2 points. Same goes for it, right? So the answer will be 1. If we also had a point at like 5, okay, let's consider that we also have a 5, okay, and we had a point somewhere here, right? So the answer, right, like this. Wait, let me decrease the size. Right. So the answer will be this. Answer will be 2 because there are no points between these 2 points and the horizontal distance between them is 2. So the answer will be 2. So we have to find the maximum horizontal distance between any 2 points. But we cannot consider this point and this point. Why? Because this point comes in between. Same case is there for this point and this point because we cannot consider this because this point is in between. We can't consider this point and this point because this point. So how can I solve this question, right? So what can I do is I can just simply sort these points according to the x coordinate, right? So these points will be arranged like this, right? So I will be going to this point, then this point, then this point, then this point, right? And if I had more points further away, right, like one point is here at 10, at 10 comma 10, or at 4 comma at 10 comma 4, right? So I would be writing first, so I would be iterating in this order. First this, then this, then this this and then this, right? So what I will be doing is I can just simply compare the distance, the horizontal distance of current point with the previous point. Okay, like if I am at this point, I will compare it with this point and just update the maximum value of the answer, right, like this. Or I can just come here and compare the distance between these 2 points, and if I am here, I will just compare horizontal distance between these 2 points and just update the answer. Same goes here. I will compare the distance of this with this and compare the answer. Same goes for this and this. So this is how we are gonna do this question. Okay, so how can we do this? Let's first sort, right? And we will be sorting according to the x coordinate, 8. So the sorting order will be in this case, first this point, second this point, third this point, fourth this point, okay, or third this point, fourth this point. The horizontal distance, the x coordinate should be sorted in increasing order. The y coordinate doesn't matter here. Why? Because between any two y coordinates, the x coordinate will be the same, so the horizontal distance will be coming as 0 always. So that's why. So the order will be first 7, then 8, then this, then this. Okay, so let's first sort. Okay, we have sorted, and will be the total number of points. Okay, so now we can just start right, we'll start from the from 1th index point because we'll be comparing it to the previous point, so that's why. Oh, also we will be up, we will be keep keeping track of the maximum horizontal distance as well. I plus plus. Okay. So we will be comparing the horizontal distance. So points I minus points of the x coordinate of the I minus 1th point. Okay, like this. And we just in the end we just return the answer. Okay, let's run this code and see. Yep. Now let's submit the solution. Yep, we got accepted, right? So let's just quickly run through the approach, right? What we'll do is we will first sort the points according to the x coordinate. Then for each point we will compare the horizontal distance of that point from the previous point, and then just update the answer with the maximum value of the horizontal distance. And we will keep doing this for all the points from the index 1 to index last. Why from 1? Because we are comparing it to the previous index, so we cannot start from index 0 because there will be no previous index. So we will start from 1. This is how we'll be doing, and in the end we will just return the answer. Okay, so now what will be the time complexity? Any sort function will have the time complexity of n log n, right? So here the sort function will be n log n. This will be this will take n log n time complexity. This is a linear time complexity piece of code, and the rest is constant time complexity. And what about the space complexity? I have not used any linear space complexity here, so the answer will be big O of 1. It's constant space complexity. Time complexity n log n, space complexity b of 1. So this is the solution for problem 1637. I hope you like it. Thank you so much. See you with the next solution.